Hey everybody, welcome to my video on continuity. We're going to be learning about continuity and discontinuities and what it means for a function to be continuous. Well, a function is continuous if you can draw it without lifting up your pencil from the paper. So if I'm drawing some function, let's say it's a line, and I draw it like this without picking up my pencil, then this function is continuous. But if we have a function like this, where I draw the line and then I lift my pencil up and then I put it back down and I keep on going, then this is not continuous. And we say that it's discontinuous. Or in other words, it has a discontinuity. Now, there are three different types of discontinuities that you need to know. There is a removable discontinuity, a jump discontinuity, and an infinite discontinuity. So let's talk about all three. If something is removable, it means it's a removable discontinuity. And what that means is you'll have a graph where a point is removed from the graph, but it could be filled in so that the two ends of the graph will meet. But if we're talking about a jump discontinuity, we still have points removed from the graph, but the two ends of the graph will never meet, even if the points are filled in. And then the last one is the easiest one to recognize. It's called an infinite discontinuity. And that's when you're graphing something and it has a vertical asymptote on either one or both sides. So down here, I have four examples of functions. And the first thing we want to do is we want to determine if they are continuous or not. So what that means is if I can graph the function without lifting my pencil from the paper, that means that the function is continuous. So if you look at the first function right here, I have y equals x squared minus 3x minus 4. And I can draw this entire graph without lifting my pencil from the paper, right? So what that means is this function is continuous. It is continuous. It has no discontinuities. And sometimes what I'll do is I will abbreviate the word continuous by writing CTS with a capital T. And that just stands for continuous. So we know that the first one is continuous. What about the second one? Well, this function is not continuous. Why is that? Well, if I start drawing the function, if I start drawing the function and I get to this point, what I have to do is, since there's a hole in the graph, there's a hole right here. What I have to do is I have to lift up my pencil and then put it on the other side of the hole and keep on drawing. So this is not a continuous function. It has a discontinuity at 1. But what kind of continuity is it? Is it a removable, or is it a jump, or is it an infinite? Well, the two ends of the graphs actually meet right here. And if I was to pick up this point and then put it in the hole, then the graph would be continuous again. So because the two ends of the graph meet, this is called removable. Removable. So we say that this function has a removable discontinuity at x equals 1. At x equals 1. So that's a removable discontinuity. Now the next one, is this function continuous? Well, I come in from the bottom and I stop right here. And then notice that I have to pick up my pencil to put it right here and then keep on drawing. So this function has a discontinuity at 1. But what kind of discontinuity is it? Is it removable? Is it jump? Or is it infinite? Well, notice that the graph does jump. It jumps from y equals 1 to y equals 2. So there's a gap here. There's a gap. And whenever you have a gap in the function where the function just jumps up, that's called a jump discontinuity. So this is a jump discontinuity at x equals 1. Okay, so that's the jump discontinuity. And then the last one, I'm graphing the function y equals 1 over x. So this is the reciprocal function. Notice that it has a vertical asymptote at x equals 0. So at x equals 0, this function starts to go crazy in the down direction and in the up direction. So this function has an infinite discontinuity. This is the infinite discontinuity at x equals 0, otherwise known as the y-axis. So if you're coming in from the left, the function goes like this, and then once it starts to get close enough to the y-axis, it starts to go down to negative infinity. And then if you're coming in from the right side, the function comes up, and then once it gets close to the y-axis, it starts to go crazy up. So if it ever has a vertical asymptote at all, it's called an infinite discontinuity. So those are the three types of discontinuities. You have removable, jump, and infinite. And if you just have one discontinuity, the function can't be called continuous. It's going to have a discontinuity to it. So that's continuity, and I hope that helps.